Service entrance cable, or SE cable, is designed for outdoor use in residential and commercial buildings. It is typically used for connecting the electrical service from the utility to the main electrical panel of the building. Service drop involves connecting from the utility's overhead lines to the weatherhead in the building. Underground service entrance is used for connecting from the underground utility feed to the meter base. It is also used for providing temporary electrical power to construction sites or other outdoor areas. There are several types of cables, wires, and classifications. Firstly, coaxial cable, which transmits data and signal over long distances and is used in television, radio, and internet. Secondly, twisted pair cable, which consists of two twisted wires and is used for telephone and data networks. Thirdly, multi-conductor cable, which contains multiple insulated conductors within a single sheath and is used for power distribution. Fourthly, fiber optic cable, which transmits light signals instead of electrical signals and offers high bandwidth and speed. There are different types of wires. Firstly, solid wire, which is a single solid conductor and is used for higher power applications and when flexibility is not required. Secondly, stranded wire, which has multiple thin wires twisted together, is more flexible and suitable for bending. Thirdly, aluminum wire, which is lighter and less expensive than copper, used in overhead lines and some industrial applications. Fourthly, copper wire conducts electricity efficiently and is used in most electrical wiring. Classifications involve conductors, American wire gauge, or AUG, which measures the diameter and current carrying capacity of wire. Conductor material includes copper, aluminum, or other materials. Stranding can be solid, stranded, or flexible. Insulation types include polyvinyl chloride, or PVC, cross-linked polyethylene, or XLPE, or other materials. Voltage rating specifies the maximum voltage the cable can safely carry. Flame resistance is the resistance to fire and heat. Armoring includes BX cable, which provides metal armoring for protection and durability, and AC cable, which is armored cable with flexible metal armoring for use in hazardous or corrosive environments. Other classifications include National Electrical Code, or NEC code, which specifies the requirements for the safe installation of electrical wiring, category, or CAT, which classifies twisted pair cables based on their bandwidth and speed capabilities, and plenum cable is rated for use in enclosed spaces where air is circulated for cooling and meets fire safety requirements. Let's delve deeper into the applications of service entrance, or C cable. This type of cable plays a vital role in connecting a building's electrical system to the main power grid. We'll explore various scenarios where SE cable is employed, including residential, commercial, and industrial settings. The information will cover the technical specifications and installation guidelines that ensure safe and efficient power distribution. Firstly, consider the service drop, which involves the connection from the utility's overhead power lines to the weatherhead of a building. The weatherhead serves as the entry point for electricity into the building, and the SE cable provides the necessary link to the main electrical panel. The selection of the appropriate SE cable for this application depends on factors such as the building's electrical load requirements, the distance between the utility pole and the weatherhead, and local electrical codes. Secondly, we'll examine underground service entrances. In this case, the SE cable connects the building's electrical system to an underground utility feed. This type of installation is common in areas where overhead power lines are not permitted or where aesthetics are a concern. The SE cable is buried underground, providing a discrete and reliable connection to the power grid. The depth of burial, the type of conduit used for protection, and the selection of appropriate connectors are critical considerations for this type of installation. Thirdly, temporary power applications involve the use of SE cable to provide electricity to construction sites, outdoor events, and other temporary locations. SE cable is well suited for this purpose due to its durability and resistance to environmental factors. The cable can be easily installed and removed as needed, providing a flexible and reliable power source. Safety is paramount in temporary power applications, and the SC cable must be properly grounded and protected from damage. Now let's explore the different types of cables and wires, and their respective classifications. This understanding is crucial for selecting the appropriate cable or wire for a specific application. We'll cover various types of cables, including coaxial cable, twisted pair cable, multi-conductor cable, and fiber optic cable. For each type of cable, we'll discuss its construction, characteristics, and common applications. Firstly, coaxial cable is designed to transmit data and signals over long distances. It consists of a central conductor surrounded by an insulating layer, a conductive shield, and an outer jacket. Coaxial cable is commonly used in television, radio, and internet applications due to its ability to carry high-frequency signals with minimal signal loss. The impedance of the cable, typically 75 ohms or 50 ohms, must match the impedance of the connected equipment to ensure optimal signal transmission. Secondly, twisted pair cable consists of two insulated wires twisted together. This configuration helps to reduce electromagnetic interference and crosstalk. Twisted pair cable is commonly used for telephone and data networks. There are different categories of twisted pair cable, such as Category 5E, Category 6, and Category 6A, each with different bandwidth and speed capabilities. Shielded twisted pair, or SDP cable, provides additional protection against electromagnetic interference. Thirdly, multi-conductor cable contains multiple insulated conductors within a single sheath. This type of cable is used for power distribution and control circuits. The conductors are typically color-coded for easy identification. The overall cable is protected by an outer jacket that provides mechanical and environmental protection. The current carrying capacity of the conductors must be considered when selecting a multi-conductor cable for a specific application. Fourthly, fiber optic cable transmits light signals instead of electrical signals. This type of cable offers high bandwidth and speed, making it suitable for high-speed data transmission applications. Fiber optic cable consists of a core, cladding, and an outer jacket. The core is made of glass or plastic and carries the light signals. The cladding surrounds the core and reflects light back into the core, preventing signal loss. The outer jacket provides mechanical and environmental protection. Now let's discuss the different types of wires, including solid wire, stranded wire, aluminum wire, and copper wire. Each type of wire has its own advantages and disadvantages, making it suitable for different applications. Firstly, solid wire consists of a single, solid conductor. Solid wire is typically used for higher power applications and when flexibility is not required. Solid wire is less prone to corrosion than stranded wire, making it suitable for harsh environments. However, solid wire is more difficult to bend and install than stranded wire. Secondly, stranded wire consists of multiple, thin wires twisted together. This configuration makes stranded wire more flexible and suitable for bending. Stranded wire is commonly used in applications where flexibility is required, such as appliance cords and automotive wiring. The stranding of the wire is specified by the number of strands and the gauge of each strand, such as 7/22, which indicates 7 strands of 22 American wire gauge wire. Thirdly, aluminum wire is lighter and less expensive than copper wire. Aluminum wire is commonly used in overhead power lines and some industrial applications. However, aluminum wire has a lower conductivity than copper wire, so it must be larger in diameter to carry the same amount of current. Aluminum wire also expands and contracts more than copper wire, which can lead to loose connections. Fourthly, copper wire conducts electricity efficiently and is used in most electrical wiring. Copper wire has a high conductivity, low resistance, and is relatively easy to work with. Copper wire is also resistant to corrosion. However, copper wire is more expensive than aluminum wire. Now let's explore the classifications of cables and wires. These classifications provide important information about the characteristics and capabilities of the cable or wire. We'll cover conductor classifications, insulation classifications, armoring classifications, and other classifications. Firstly, conductor classifications include American wire gauge, or AUG, conductor material, and stranding. American wire gauge measures the diameter and current carrying capacity of wire. The smaller the American wire gauge number, the larger the wire diameter and the higher the current carrying capacity. Conductor material can be copper, aluminum, or other materials. The choice of conductor material depends on the application and the desired characteristics. Stranding can be solid, stranded, or flexible. The stranding affects the flexibility and ease of insulation of the wire. Secondly, insulation classifications include insulation type, voltage rating, and flame resistance. Insulation type can be polyvinyl chloride, or PVC, cross-linked polyethylene, or XLPE, or other materials. The choice of insulation type depends on the application and the desired characteristics, such as temperature rating, chemical resistance, and dielectric strength. Voltage rating specifies the maximum voltage the cable can safely carry. The voltage rating must be appropriate for the application. Flame resistance is the ability of the insulation to resist fire and heat. Flame-resistant cables are required in many applications to prevent the spread of fire. Thirdly, armoring classifications include BX cable and AC cable. BX cable, also known as armored cable, provides metal armoring for protection and durability. EX cable is commonly used in residential wiring. AC cable, also known as flexible metal conduit, provides flexible metal armoring for use in hazardous or corrosive environments. AC cable is commonly used in industrial applications. Finally, other classifications include National Electrical Code, or NEC, code, category, or CAT, and plenum cable. National Electrical Code specifies the requirements for the safe installation of electrical wiring. Compliance with National Electrical Code is essential for ensuring the safety of electrical systems. Category classifies twisted pair cables based on their bandwidth and speed capabilities. Plenum cable is rated for use in enclosed spaces where air is circulated for cooling. Plenum cables meet fire safety requirements to prevent the spread of fire in these spaces. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the National Electrical Code is essential for ensuring the safety of electrical systems and preventing electrical hazards. The National Electrical Code is adopted by many jurisdictions as the basis for their electrical codes. It is important for electricians, electrical contractors, and building inspectors to be familiar with the National Electrical Code and to follow its requirements. The American Wire Gauge, or AUG, is a standardized system for measuring the diameter and current carrying capacity of wires. The American wire gauge number is inversely proportional to the wire diameter. The smaller the number, the larger the wire. The American wire gauge system is used to specify the size of wires for various applications. The American wire gauge also specifies the current carrying capacity of wires. The current carrying capacity is the maximum amount of current that a wire can safely carry without overheating. The current carrying capacity depends on the wire diameter, the insulation type, and the ambient temperature. It is important to select the appropriate wire size for an application to ensure that the wire can safely carry the required current. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Voltage drop can affect the performance of electrical equipment. Excessive voltage drop can cause lights to dim, motors to run slowly, and other equipment to malfunction. It is important to minimize voltage drop in electrical systems. Voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance. The resistance of a conductor depends on the conductor material, the conductor length, and the conductor cross-sectional area. The National Electrical Code provides guidelines for minimizing voltage drop in electrical systems. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Grounding also helps to prevent the buildup of static electricity, which can damage electronic equipment. The National Electrical Code specifies the requirements for grounding electrical systems. Overcurrent protection is the use of fuses or circuit breakers to protect electrical circuits from excessive current. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a predetermined level. Overcurrent protection devices help to prevent electrical fires and equipment damage. The National Electrical Code specifies the requirements for overcurrent protection. Short circuits occur when there is a low resistance path between two conductors that are normally at different voltages. Short circuits can cause a large amount of current to flow, which can damage equipment and cause electrical fires. Overcurrent protection devices are designed to protect against short circuits. Ground faults occur when there is a low resistance path between a conductor and ground. Ground faults can cause a shock hazard if someone comes into contact with a grounded object. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults. GFCIs are required in many locations, such as bathrooms and kitchens. Arc faults occur when there is an unintended electrical discharge between two conductors. Arc faults can cause electrical fires. Arc fault circuit interrupters, or ASIs, are designed to protect against arc faults. ASIs are required in many locations, such as bedrooms. Electrical safety is essential for preventing electrical hazards. It is important to follow safe work practices when working with electricity. Always turn off the power before working on electrical circuits. Use insulated tools and equipment. Never work in wet conditions. If you are not qualified to work with electricity, hire a licensed electrician. Electrical permits are required for many types of electrical work. Electrical permits ensure that the work is done safely and in accordance with the National Electrical Code. Contact your local building department to obtain an electrical permit. Electrical inspections are performed by building inspectors to ensure that electrical work is done safely and in accordance with the National Electrical Code. Electrical inspections are typically required after electrical work is completed. Contact your local building department to schedule an electrical inspection. The selection of appropriate electrical cables and wires involves several considerations. The ampacity, or current carrying capacity, of the conductor must be sufficient for the intended load. The voltage rating of the cable or wire must be adequate for the system voltage. The environmental conditions, such as temperature and moisture, must be taken into account. The installation methods must be appropriate for the type of cable or wire. The National Electrical Code provides guidance on the selection and installation of electrical cables and wires. Proper termination of electrical cables and wires is essential for ensuring safe and reliable connections. Use appropriate connectors and tools. Follow the manufacturer's instructions. Ensure that connections are tight and secure. Inspect connections regularly for signs of corrosion or damage. Cable trays are used to support and route electrical cables and wires. Cable trays can be made of metal or non-metallic materials. Cable trays must be properly grounded. Cable trays must be sized appropriately for the number and size of cables. Conduit is used to protect electrical cables and wires from physical damage and environmental conditions. Conduit can be made of metal or non-metallic materials. Conduit must be properly supported. Conduit must be sized appropriately for the number and size of cables. The fill capacity of conduit is the maximum percentage of the conduit's cross-sectional area that can be occupied by cables. The National Electrical Code specifies the fill capacity of conduit. Cable glands are used to provide a secure and watertight connection between a cable and an enclosure. Cable gland must be appropriate for the type and size of cable. Cable glands must be properly installed. Cable ties are used to bundle and secure electrical cables and wires. Cable ties can be made of plastic or metal materials. Cable ties must be appropriate for the environmental conditions. Cable markers are used to identify electrical cables and wires. Cable markers can be made of various materials. Cable markers must be legible and durable. Testing of electrical cables and wires is essential for ensuring their integrity and performance. Continuity testing verifies that there is a complete electrical path. Insulation resistance testing measures the resistance of the insulation to ground. Voltage testing verifies that the voltage is within acceptable limits. Cable fault locators are used to identify the location of faults in electrical cables. Maintaining electrical cables and wires is essential for ensuring their long-term reliability. Inspect cables and wires regularly for signs of damage or deterioration. Repair or replace damaged cables and wires promptly. Keep cables and wires clean and free from debris. Following these guidelines, along with adhering to the National Electrical Code and local regulations, will help ensure the safe and efficient operation of electrical systems.